Hello everyone, today we'll be going over Mathematics, May June 2021, Paper 5.3. This is Probability and Statistics first, and we have a time limit of 1 hour and 15 minutes. So let's get started. For the first question, we're given the heights in centimeter of 160 sunflower plants, and the results are summarized in the following cumulative frequency curve. We can see that this is a less than cumulative frequency curve, so this is less than CF. And how do we identify whether if it's a less than CF is if it's starting from the lowest point, which is 0, that will be less than CF. If it's starting from the highest point on the cumulative frequency, that will be a more than curve. And in A levels, we only study about the less than cumulative frequency curve. We need to figure out the number of plants with heights less than 10 centimeter. And in order to figure out this number, we're going to use the graph. Alright, since I already told that this is a less than curve, which means that if we're going to need the numbers of sunflowers that is less than 40 centimeter, we can just look up straight. So 40 is right here, and then the corresponding CF will be the required number, which in this case I think will be 16. So 16 sunflowers will have a height of less than 40 centimeters. So we need to figure out the same for 100 centimeter. So here is 80 and that's 120. So right in the middle, that's going to be the 100 centimeter. All right, then the straight line through it will be right here. So this point. And the corresponding cumulative frequency is 60, which means that 60 sunflowers are going to have the heights less than 100 centimeter. So the required answer for question A will be 60. So for the second question, we need to use the graph to estimate the 65th percentile of the distribution. So this is just going to be that point in which the number of sunflowers out of 160, so that's going to be 65% of sunflowers less than a certain point. So we're going to figure out that point, which will be in centimeter. So we know that the total number of sunflowers is 160. So the 65th percentile of the sunflower is going to be just 65% of 160. That's going to be 65 by 100 into 160, which is going to be 104. So we require the heights in centimeter for which 104 sunflowers are going to be less than that particular height. So let's look at the graph. So we have the 100 sunflowers right here. We need to look for 104 sunflowers. So that's going to be here. That's 104, and then the corresponding point in the curve is going to be this point. Now the corresponding point on the height axis or the x-axis is going to be right here. Alright, we know that here is 120, here is 160, which means that this point is going to be 140. And this is the fourth point in between 120 and 140, which means that the required height will be 136. So that is going to be the 65th percentile of the distribution. That's going to be the height of 136 centimeter. So this just means that 65% of the total sunflowers, which is 160, that's going to be 104. So this just means that 104 of the sunflowers are going to have a height less than 136 centimeter. Now for the third question, we need to use the graph in order to estimate the interquartile range of the heights of these plants. So we know that interquartile range, it's just going to be the upper quartile of Q3 minus the lower quartile of Q1. And if we draw a line to represent all of the data, so the lowest point is going to be the smallest value, the highest point is going to be the largest value, and in between there's going to be the median, so that's Q2. And in between the smallest value and the median, there's going to be the lower quartile of Q1, and in between the median value and the largest value, there's going to be the upper quartile Q3. So this just means that this is at 0%, that's 25, that's 50, that's 75, and the highest value is going to be obviously the 100% one. So we need to figure out Q3 and Q1. So in order to figure out these values, we need to figure out the 75th percentile and 25th percentile. So we're just going to repeat the same process that we did for the second part of this question. So for 75%, that's just going to be 75% of 160, which is going to be 75 by 100 into 160, which will be equal to 120. So that's going to be the number of sunflowers, and we need to figure out the corresponding height for which these sunflowers is going to be less than that particular value. So 75th percentile, that's the upper quartile Q3. So we need to look at the graph again. So we're looking at 120 sunflowers, which is right here. Then the point on the curve will be right here. Alright, then the corresponding point on the x-axis or the height axis will be somewhere around here. So if this is 140, that's going to be 144, that's going to be 148. So this number is somewhere in between 148 and 152. So let's just assume it to be in the middle. So that's going to be 150. So 150 centimeter will be the upper quartile value. Alright, now we need to figure out the lower quartile, which means that we need to figure out the 25th percentile. So that's going to be 25% of 160, which is 25 by 100 into 160. This gives us a value of 40. So we're looking for a number on the height for which 40 sunflowers are going to be less than that particular height. So that's 25th percentile, or the lower quartile Q1. So we're looking at the graph again for 40 sunflowers. So that's going to be right here. And the point on the curve is here, which has a corresponding point on the height axis right here. So that's 80, which means that this value is going to be 76. So the lower quartile will have a value of 76. So that's 76 centimeter. Now we need to figure out the interquartile range. So let's just substitute the value. That is 150 minus 76, which gives us the interquartile range of 74 centimeter. The random variable x can take only the values -2, -1, 0, +1, and +2, and the probability distribution of x is given in the following table. So we're given the values p, p, and q. So we're also given that the probability of x greater or equals to 0, which means that this includes the value 0 as well, is equals to 3 times the probability of x less than 0, which means that this does not include the value 0. We need to figure out the values of p and q. Since we need to figure out the values for two different variables, we need to figure out the two different equations first. So the first equation will be to sum all these probabilities. So we know that the total probability should always be equal to 1, right? So that's going to be our first equation. So that's p plus 0.1 plus q is going to be 1. That's just 2p plus 2q equals to 0.9. So let's put it in terms of q. So that's p equals to 0.9 minus 2q divided by 2. Alright, now we need to form the second equation. So that's going to be right here, this one. So we need the probability x greater or equals to 0. So that's going to be 0, 1, and 2, and their respective probabilities, that is 0.1 plus q is equal to 3 times the probability for x is less than 0. So that's just the probabilities for -2 and -1. p plus p. So this is going to be 0.1 plus 2q equals to 3 into 2p. Now let's substitute the value of 0.9 minus 2q divided by 2 for p in this second equation. So that's just going to be 0.1 plus 2q equals to 3 into 2 into 0.9 minus 2q divided by 2. So the two and this 2 cancels out. Now it's going to be 0.1 plus 2q is equal to 3 into 0.9, which is going to be 2.7 minus 3 into 2, that's just 6q. Alright, I'm going to bring this q to this side. So that's going to be 6q plus 2q equals to 2.7 minus 0.1. This is going to be 8q is equal to 2.6. That's going to be q equals to 2.6 divided by 8, which gives us the value for q at 0.325. Alright, in order to figure out the value for p, we're just going to substitute this value of q. So that's going to be p equals to 0.9 minus 2 into 0.325 divided by 2, which is going to be 0.9 minus 0.65 divided by 2, which gives us the value of p at 0.125. A sports club has a volleyball team and a hockey team, and the heights of the 6 members of the volleyball team are summarized by summation x and summation x square, where x is the height of a member in centimeter. Then the heights of the 11 members of the hockey team are summarized by summation y and summation y square, where y is the height of a member in centimeter as well. So we need to figure out the mean height of all 17 members of the club. So we know the formula for mean to be summation x divided by n, but in this case the summation x is broke down into 2 different parts. So that's going to be summation x plus summation y, because we're considering the heights of all the players, which means that 6 players will be from the volleyball team. Their height is represented by summation x, and then the 11 members are of the hockey team and their heights are represented by summation y. Alright, now mean height is going to be summation x plus summation y divided by n. Now n is also given in 2 different parts. So the first one is the players in the volleyball team, that's 6, plus the players in the hockey team, so that's going to be 11. Let's just substitute the values for summation x and summation y. That's going to be 1050 plus 1991 divided by 6 plus 11. This gives us the mean height as 3041 divided by 17, which is going to be 178.9 centimeter. So that's the mean height of all 17 members in the club. Now we need to figure out the standard deviation of the heights of all 17 members of the club. Alright, we know that the formula for standard deviation is going to be root under summation x squared divided by n minus mean squared. So we already have this value. The mean is of 178.9, which we figured out in the first part. Now this value is also going to be broken into 2 different parts, because that's going to be summation x squared plus summation y squared. This will represent the squared values of the heights of 6 players in the volleyball team, whereas this represents the squared values of the height of the 11 players in the hockey team. So the required standard deviation is going to be root under summation x squared plus summation y squared divided by total number of players. So that's just going to be 6 of the volleyball team and 11 of the hockey team minus the mean value squared. So we already figured out the mean value to be 178.9. We just need to square this value. Alright, now we need to substitute the values for summation x squared and summation y squared. That's going to be 193,700 for x. So 193,700 plus for y it's going to be 366,400. So that's 366,400 divided by 6 plus 11 minus 178.9 squared. Alright, I'm going to compute this value first. So that's going to be root under 560,100 divided by 17 minus 178.9 whole square. So this gives us the total standard deviation value of 30.690. Three ferrous six-sided dice, each with faces marked 1, 2, 3, 4, 5, and 6, are thrown at the same time repeatedly. For a single throw of the three dice, the score is the sum of the numbers on the top faces. So we need to figure out the probability that the score is 4 on a single throw of the three dice. So let's just represent the variable x1 to be the score on the first die, x2 to be the score on the second die, and x3 to be the score on the third die. And we need to figure out the sum. This needs to be equal to 4. So let's just list out the possible combinations. That's going to be a score of 1, a score of 1, and another score of 2. Or it can be a score of 1, score of 2, and another 1. Or it can be a score of 2, score of 1, and a score of 1. Now, since all three dice are fair dice, so the probability of 1 is going to be 1 by 6, and the probability of 2 is also going to be 1 by 6. So that's going to be 1 by 6 into 1 by 6 into 1 by 6, which is 1 by 216. Again, that's going to be 1 by 6 cube. That's also 1 by 216. And again, that's 1 by 6 cube. That's going to be 1 by 216. So the required probability is just going to be the sum of these three different probabilities. So that's 3 times 1 by 216, which is going to be 1 by 72. For the second part, we need to find the probability that a score of 18 is obtained for the first time on the fifth throw of the three dice. So this is going to be a geometric distribution, right? Geometric distribution has the parameter p. So this p will be the probability of a score of 18. So we need to figure that out first. So we know that we have three die, first one, second one, third one. And the sum of score on these three die is going to be 18. So the possible conditions, there's just one condition. So that's the score of 6 on all three die. That's going to be 1 by 6 to the power 3, which is going to be 1 by 216. So the parameter p is going to be 1 by 216. Alright, and we need to obtain the score of 18 for the first time on the fifth throw. So that's going to be 5 throws, and we need success over here, which means that we need to have 4 failures before the first success. And if the probability of success is going to be 1 by 216, then the probability of failure is going to be 1 minus 1 by 216, which is going to be 215 by 216. Alright, let's just figure out the required probability. So we require 4 failures. That's going to be this probability to the power 4. So 215 by 216 to the power 4 into the probability of success, which is given by 1 by 216. This gives us the total probability of 0.00454. That's the required answer. The lengths of the leaves of a particular type of tree are modeled by a normal distribution. A scientist measures the length of a random sample of 500 leaves from this type of tree and finds that 42 are less than 4 cm long and 100 are more than 10 cm long. We need to figure out the values for the mean and standard deviation of the lengths of leaves from this type of tree. Alright, I'm going to denote the variable x to be the length of the leaves. And we're given that x follows a normal distribution, but we do not know the values for the parameters. That's going to be the mean mu and then sigma squared, the variance. Alright, next we're given that from a random sample of 500 leaves, the scientist finds that 42 are less than 4 cm long. So the probability that x is less than 4 is just going to be 42 out of 500. So that's 42 by 500. And the next probability is that out of 500, 100 are more than 10 centimeter long. So that's probability x is greater than 10 is going to be 100 out of 500. So that's going to be 100 by 500. Alright, since we know that x follows the normal distribution, the first step would be to standardize. So that's going to be z is less than 4 minus mean value. We do not know the value, so that's just going to be the parameter mu divided by the standard deviation sigma. That's going to be equal to 42 by 500, which is 0.084. And then we have the probability p, z is greater than 10 minus mu divided by sigma equals to 100 by 500, which is equivalent to 0.2. All right. Now the first step is done. So the second one is to drop the distribution. So this is 0, and we're looking for this point. And the probability less than this point is going to be 0.084. So since we know that the probability to the left side of the mean is going to be 0.5, this point of 4 minus mu by sigma is going to be somewhere around the tail. And this probability is going to be 0.084. Alright, we can just flip this probability using the symmetricity property. So that's going to be, if this side has a value of 4 minus mu by sigma, then this side is going to have the value of mu minus 4 by sigma, because these are going to have opposite signs. And then the probability greater than this value is going to be 0.084, which means that the probability less than this value of mu minus 4 divided by sigma is going to be 1 minus 0.084, which is 0.916. So we're going to find the corresponding z value for this probability. Alright, let's just do this for the second equation as well. Alright, for the number 10 minus mu by sigma, the probability greater than this value is going to be 0.2. Again, since we know that the probability to the right hand side of mean is going to be 0.5, which means that this value is going to be somewhere around here. So that's 10 minus mu by sigma, and the greater portion has the probability of 0.2, which means that the probability less than this number is going to be 1 minus 0.2, which is 0.8. So we're going to look for the corresponding z value for the probability of 0.8 and 0.196. Let's just go to the normal distribution table. Okay, let's first look for the probability of 0.916. So the closest one is here, but we need to find the exact value. So since we have 0.9147 here, let's figure out the difference first. So we need the value of 0.916, and we're given the value of 0.9147. The difference here is going to be 0.0013, which means that if 13 is added to this, we'll have a probability of 0.916, and 13 is given right here. So that's going to be the z value of 1.3, and the corresponding column is going to be 7. So the second digit will be 7, and the third one is going to be the corresponding value of 8. So the third digit is going to be 8. So for the probability of 0.916, the corresponding z value is going to be 1.378. Let's look for the probability of 0.80 now. So the closest one is right here, that's 0.7995. Let's figure out the difference for this one as well. That's 0.8 minus 0.7995. That gives us a difference of 0.0005, which means that if 5 is added to this probability value, we'll get the total probability of 0.8. And 5 is given right here. So the corresponding z value is going to be 0.8, the corresponding column, which has 4, so that's the second digit, and the corresponding column has 2, so that's going to be the third digit. So for the probability of 0.8, the corresponding z value is going to be 0.842. Let's just substitute these both values. Alright, for the probability of 0.196, this corresponding value is going to be 1.378, and for the probability of 0.8, this corresponding value is going to be 0.842. Let's solve the equations. So the first equation is going to be mu minus 4 divided by sigma is equal to 1.378. I'm going to write this in terms of sigma. So that's going to be sigma equals to mu minus 4 divided by 1.378. Then the second equation is going to be 10 minus mu divided by sigma equals to 0.842. Writing this in terms of sigma, that's going to be 10 minus mu divided by 0.842. So let's just equate these two equations. That's going to be mu minus 4 by 1.378 equals to 10 minus mu divided by 0.842. So cross multiplying it, we receive 0.842 mu minus 4 into 0.842, which is 3.368. Then we have 10 into 1.378, that's going to be 13.72 minus 1.378 mu. So if we bring this term of mu to this side, that's going to be 1.378 plus 0.842, which is 2.22 mu. And bringing this side to the right hand side, that's going to be 13.72 plus 3.368, which is 17.088. So mu is going to be 17.088 divided by 2.22, which gives the value of 7.697. Now, the value of sigma can be figured out by just substituting the value of mu. So that's going to be sigma equals to 10 minus 7.697 divided by 0.842. This gives us the value of sigma to be 2.735. Now, the lengths in centimeter of the leaves of a different type of tree have the distribution normal with the parameters mu and sigma square. Then the scientist takes a random sample of 800 leaves from this type of tree. Find how many of these leaves the scientist would expect to have lengths in centimeter between mu minus 2 sigma to mu plus 2 sigma. So we're just going to find the probability of x taking the values between mu minus 2 sigma to mu plus 2 sigma. Alright, and what we know is that x follows normal distribution with the parameters mu and sigma square. So since we know that x follows a normal distribution, the first step would be to standardize. So that's going to be mu minus 2 sigma minus mu divided by sigma is less than z is less than mu plus 2 sigma minus mu divided by sigma. The positive and the negative mu are going to cancel each other out. So that's going to be probability negative 2 sigma by sigma is less than z is less than 2 sigma by sigma. Again, the sigma on the numerator and the denominator are going to cancel each other out as well. So that's going to be negative 2 to 2. So we're just finding out this probability. Let's just drop the probability distribution. So 2, that's somewhere around here and here. So we need to figure out this area. And since we know the symmetricity property, this area is going to be equal to this area. So if we just figure out the area for this portion and multiply it by 2, we're going to receive the required value. In order to do so, we're first going to figure out the total probability less than 2, which will also include this area which is not required. And we know that the area to the left hand side is going to be 0.5. So we just subtract this value and then multiply it with 2 because we're requiring the probabilities for two different sides. That's just going to be 2 times probability z is less than 2 minus 0.5. So we're going to find this value from the normal distribution table. We're looking for probability less than 2, so we're looking at the z value of 2, which is given right here. And it has the probability of 0.9772. We're just going to substitute this value. So that's going to be 2 times 0.9772 minus 0.5, which is going to be 2 times 0.4772. This gives us the final probability of 0.9544. Alright, this is the probability for a single leaf, right? But we're asked how many of these leaves, which means that we need to figure out how many of the 800 leaves would expect to have lengths between mu minus 2 sigma and mu plus 2 sigma. That just means that we need to multiply the probability that we just figured out by the total number of samples, which is 800 in this case. So the number of leaves required is just going to be the product of the total sample, which is 800, and the probability that it lies between mu minus 2 sigma and mu plus 2 sigma, which is 0.9544. So this gives us the total leaves of 763.52, which can be rounded off as 764, or it can be written as 763 as well. Both are going to be correct. How many different arrangements are there of the 11 letters in the word requirement? Alright, so I'm just going to list the total number of letters denoted by n, which is going to be 11. I'm also going to list the repeated letters. So we have 2 repeated letters in this word, so that's R and E. And R occurs 2 times, whereas E occurs 3 times. Now we need to figure out the number of different arrangements. So that's just number of arrangements, but we're not given any restrictions. So this is a case without any restriction. And this is just going to be the total number of letters factorial divided by the repeated number of letters factorial. In this case, that's going to be R1 factorial into R2 factorial, which is 11 factorial divided by 2 factorial into 3 factorial, which gives us the total number of arrangements at 3,326,400. Alright, for the second part, we need to figure out the different arrangements of the 11 letters in the word requirement in which 2 R's and 3 E's are together. So we're just considering 2 R to be a single letter, the 3 E to be a single letter, and then the remaining letters are going to be Q, U, I, M, N, and T. So in this case, the total number of letters N is just going to be 6 plus 1 plus 1. So that's going to be 8. And there are not going to be any repeated letters. Alright, so the number of arrangements but this is a case with restriction, and the restriction is that R should be together and E should be together as well. So that's just going to be the total number factorial. We do not have any repeated letters, but we also need to consider the arrangement of these 2 R's and these 3 E's, but the total number of letters here is just 2, and the repeated is also 2, so that just cancels each other out, right? Same for the case of E as well. So the total number of letters is going to be 3, and the repeated is also going to be 3 factorial, which means that the number of arrangements is just going to be 8 factorial. But if there were to be different letters, suppose E, R, and A, that would have been a different case, because the total number of letters would be 3, but there would be no repeated letters, right? So that would have made a change in the total number of arrangements as well. But in this case, it doesn't matter if you do not include it. So that's 8 factorial, which gives 40,320 ways of arrangements. For the third one, we need to figure out the different arrangements of the 11 letters in the word requirement, in which there are exactly 3 letters between the 2 R's. So we know that there are exactly 11 letters. So that's 5, 6, 7, 8, 9, 10, 11. Alright, so the first possible choice would be to have R in the first position, maintain 3 gaps, and then the second R would be on the 5th position. The second possibility would be to have first R in the second position and second R on the sixth position. The third possibility would be to place the first R on the third position, second R on the seventh position. Fourth one would be to have first R on the fourth position, second R on the eighth position. That's supposed to be R. Alright, for the fifth placement, we can have the first R on the fifth position, second R on the ninth position. For the sixth placement, we can have first R on the sixth position and the second R on the 10th position. And for the seventh placement, we can have first R on the seventh position and the second R on the 11th position. Now, these are the total possibilities. We can't have another possibility because this considers the first letter and the last letter, and in between whatever placements there could have been. So we just need to figure out the arrangement of the remaining 9 letters, because for the remaining 2 letters of the word requirement R and R, we're already considering it, and we already figured out that there are going to be 7 possibilities. So we can completely ignore these 2 letters and just figure out the number of arrangements for the remaining 9 letters, right? So for the total letters, that's going to be 9, and then the repeated letters, there's just going to be E, and the number of time it repeats is going to be 3. So the required number of arrangements now is just going to be total number factorial divided by repeated number factorial, but this only considers the 9 letter. In order to consider the 2 R's, we need to multiply it with the number of possibilities. So that's 7. So that's into 7, which gives us the total number of arrangements of 423,360. Now, 5 of the 11 letters in the word requirement are selected, and we need the possible selections containing at least 2 E's and at least 1 R. Alright, so the number of E are 3. The number of R is going to be 2, and then the remaining letters are going to be 11 minus 3 minus 2, which is going to be 6 remaining letters. And we are to select 5 from these letters, which contains at least 2 E's and at least 1 R. So let's just list down the possibilities first. Let's start with 2 E's, 1 R, and then the remaining 2 letters can be from this remaining letters of 6, right? Or let's increase the value for E. That's going to be 3 E's, 1 R, and 1 remaining letter. Let's increase the value for R. That's going to be 2E, 2 R, and 1 remaining letter. Next, it can be 3 E's and 2 R and no remaining letters at all. Alright, these are the possible selections. So since we're considering all the possibilities for E's and R, we can just figure out the remaining letters combinatorial and we'll get the answer. So in this case, that's going to be 2 out of 6. So that's going to be 6C2, which is 15. For the second case, that's going to be 6C1, which is going to be 6. For the third case, that's going to be 6C1 as well, which is 6. And for the final case, that's going to be 6C0, which is going to be 1. So the number of possible selections are just going to be the number of possible selection is just going to be the sum of these 4 values, right? So possible selections is going to be 15 plus 6 plus 6 plus 1, which gives us the total value of 28. In the region of Arka, the total number of households in the 3 villages, Rita, Shan, and Teber, is 800, and each of the households was asked about the quality of their broadband service. Their responses are summarized in the following table. We need to figure out the probability that a randomly chosen household is in Shan and has poor broadband service. So we know that the total of all these 9 values is going to be 800. Alright, so the required probability here is that the household is in Shan. So this is we're considering this value, and has a poor broadband. So poor broadband is right here. So we're looking at the intersection of these two events, which is given by 40. So that's 40 out of 800, which gives us the probability of 0.05. Now, for the second part, we need to find the probability that a randomly chosen household has good broadband service, given that the household is in Shan. So required probability is that it has a good broadband service, given that the household is in Shan. So this is just going to be the intersection of the two events, which means that the household has good broadband service and the household is in Shan, divided by the probability that our household is in Shan. Okay, let's figure out the first probability first. That's good and Shan as well. So we already know that Shan is given right here. But if we're looking for the good, and the intersection of these two events is going to be 177 out of 800. So that's going to be 177 out of 800 divided by, we're finding the total probability that the household is in Shan. So that's just going to be the sum of these three numbers. So that's 223 plus 177 plus 40, which gives us the total of 440. So the probability that the household is in Shan is going to be 440 divided by 800. So the 800 just cancels out. This simplifies to 177 by 440, which is going to be 0.402. Now, in the whole of Arca, there are a large number of households, and a survey showed that 35% of the households in Arca have no broadband service. Now, 10 households in Arca are chosen at random. That's going to be our number of samples. We need to figure out the probability that fewer than 3 of these households have no broadband service. So I'm just going to denote X with the number of households having no broadband service. Alright, we know that X follows a binomial distribution because we are given the sample and the probability. So that's going to be 10, the probability is of 35%, which can be written as 0.35. And we are to find the probability that X is less than 3. This just includes the values 0, 1, and 2. So this is going to be probability X equals to 0 plus probability X equals to 1 plus probability X equals to 2. Now let's just use the formula for binomial distribution, but we know that P is 0.35. Let's just figure out the value for Q as well. That's going to be 1 minus 0.35, which is 0.65. Alright. So probability X equals to 0 is going to be 10C0 into 0.35 to the power 0 into 0.65 to the power 10 plus 10C1 into 0.35 to the power 1 into 0.65 to the power 9 plus 10C2 into 0.35 square into 0.65 to the power 8. Alright. I'm going to write it till 4 decimal places. So 10C0 into 0.35 to the power 0 into 0.65 to the power 10 is going to be 0.0135 plus 10C1 into 0.35 to the power 1 into 0.65 to the power 9 is going to be 0.0725 plus 10C2 into 0.35 square into 0.65 to the power 8 is going to be 0.1757. So this gives us the total probability of 0.2617. If we are to round it off to 3 decimal places, that's going to be 0.262. Now 120 households in Arca are chosen at random. So now the number of samples is going to be 120, and we are to use an approximation. This means that we are to convert the binomial distribution into the normal one in order to find the probability that more than 32 of these households have no broadband service. Alright, so this just means that X follows a binomial distribution with the sample of 120, and since X is still the event of households not having any broadband service, the probability is going to be 0.35. In order to convert a binomial distribution into a normal one, we need to figure out its parameters. And we know that the parameters of the normal distribution is going to be mean and variance. So let's just figure out the mean first. So the mean for binomial distribution is going to be n into p. In this case, that's 120 is into 0.35, which gives us the value of 42. That's going to be the mean value. For the variance, that's going to be n into p into q. In this case, that's 120 into 0.35 into 0.65, which is going to be 27.3. So the parameters for normal distribution is going to be mu with the value of 42 and sigma square with the value of 27.3. Alright, now we need to figure out the probability that x is more than 32. So that's greater than 32. But since we know that we're converting a discrete distribution, since binomial distribution is a discrete one, to a continuous distribution. Normal is a continuous distribution. We need to perform a continuity correction. So that's 32, that's 32.5, and this is going to be 31.5. And we're looking at the greater side. Alright, but we can see that there is no equals to sign, which means that 32 should not be included. So we're going to ignore the 32 and look at the greater side, which means that that's going to be greater than 32.5. So that's probability x is greater than 32.5. Now we can move on to applying the normal distribution process. So the first step would be to standardize. That's z is greater than 32.5 minus the mean value of 42 divided by the standard deviation. That's going to be root under variance. This gives us the value of negative 1.818. Alright, let's just drop the probability distribution. So this is the mean, and we're looking at the probability greater than negative. So that's going to be on the left hand side. Right, somewhere around here, that's negative 1.818, and we're requiring the probability greater than this value. Alright, using the symmetricity property, we can just flip this figure. So that's going to be 0. Somewhere around the right hand side is going to be positive 1.818, and the probability less than this value is going to be the same as the probability greater than negative 1.818. So this can just be written as probability z is less than positive 1.818. So we're going to look at the probability in the normal distribution table now. So we're looking at the z value of 1.818. So that's going to be 1.8 right here. And the second digit is a 1. So that's going to be right here. And the third digit we require is of 8, which is given in this column. So that's going to be the corresponding value of 6. Okay, let's just add it together. That's going to be 0.9649 plus 0.0006. This gives us the final probability of 0.9655. Alright, we'll substitute this value. So the probability z is less than positive 1.818 is going to be a value of 0.9655. If we are to round it off to 3 figures, that's going to be 0.966. Alright, this brings us to the end of this set. If you found this video useful, make sure you hit the like button, make sure to leave a comment below, and make sure to subscribe and hit the bell icon in order to view more of these contents in the future. Thank you.